Hi, my name is Steve Rahi. I am a Premier Field Engineer specializing in System Center Technologies. Today's discussion will be part 2 of a series that we're doing talking about replication, data replication in Configuration Manager 2012. So there'll be a total of three parts to this discussion. Part 1 was basically an introduction to the concepts of data replication, talking about how in Configuration Manager 2012 data movement throughout the hierarchy is really classified into two big broad buckets. The first is file-based replication, and the second being Config Manager SQL replication. So this is part 2, and here we're going to do a deep dive into file-based replication, and then part 3 we'll go into specifically Config Manager SQL replication. So in terms of file-based replication, we need to talk about what specifically is replicated. And really, for file-based replication, the lion's share of the information that is replicated using that mechanism is content. So content, meaning the source files, the actionable files that you need for deployment, such as a software updates deployment, or a package, or an application, or something like that, right? That's the lion's share. That's not all that is replicated using file-based replication, but certainly that's most of it. Here's another point to make. When we think of file-based replication in previous versions, Config Manager 2007, SMS 2.0, SMS 2003, what we're talking about is the communication that happens between two site servers that are in a parent-child relationship. And that's certainly true here as well. The difference is, since we're talking primarily about content in Configuration Manager 2012, you can kind of think as replication being that mechanism that gets the content from one site to another and ultimately to a distribution point on that child site. While that's really not exactly true, all we're really trying to do is get the files from one site to another. It kind of holds in 2012 because really most of the content that we're going to replicate is going to be destined for a distribution point. So actually, you'll see in the demos today that I will be sending content all the way through to distribution points. But in reality, all that we really need to do is get the content from site to site, and then other mechanisms would kick in to get it to distribution points that aren't really part of the replication scheme, but we'll follow it through just for completion. Other things that you might see being replicated might be, in some cases, discovery records. In the case of software updates, we have a synchronization process that needs to happen so that you can get the latest updates from Microsoft Update, and then that information gets down to your child software update point. So let me explain that for a minute. When we synchronize data for our software update point from Microsoft Updates at the CAS, right, that's metadata. There's no content, no actual patch files that are coming down as a part of that synchronization. It's just metadata. So in Config Manager 2012, as you see on the right-hand side, metadata is really replicated by Config Manager SQL replication, and that's certainly true of software update metadata as well, right? But there is a need for the child site's software update point to synchronize its database based on what was synchronized at the CAS. So once the CAS finishes its synchronization, one of the last things you'll notice in the log is a statement that it's going to send a sync notification down to the child sites. Well, that's in the form of a file. So we're not replicating the metadata by file-based replication, but we are replicating the synchronization file by file-based replication. Long explanation just to point out there's other things that go through the system besides actual content files through file-based replication. But again, vast majority of all of the file-based replication is through content, right? And that's what we'll focus on today. So historically, anything, it was site control file data, status data, collection updates, everything went through the file-based mechanism. Not today. All of that, the metadata, goes through Config Manager SQL replication we'll cover in part 3. So to kind of illustrate this, I really want to walk through 3 scenarios. This first scenario is one that you could really consider to be classic site-to-site file-based replication, right? And then the other 2 scenarios will build on top of this. So what I have here is a CAS and a child primary site that is also happening to be a distribution point. And what I've lined out are the various components that are involved in sending data from one site to another, in this case the CAS to the primary. Now, you could just as easily reverse this flow, and the primary might need to send data to the CAS. That's fine too, and we could do these steps backwards. Just turn the picture upside down, right? But what happens is when we're at the CAS, an administrator might take an action like add a distribution point to a package or an application or deployment, a software updates deployment package, whatever. All of that is done through the admin console. Well, when you do things through the admin console, there's a component called the SMS provider that actually writes that information to the database, interacts with that data, puts it in the database. Having that information in the database isn't really enough. We need to replicate some of the data down, especially whenever we're telling ConfigMgr to use source files, right? So what happens is there's a component called SMSDBmon that watches the database for certain changes and then reacts accordingly. This is not just a component for packages. It works with applications, it works with software updates, and watches certain key tables inside the database, and when data is added, it will wake up further components in line to cause processing to take place. Okay, so again, we're focusing on a package right now, but in general, the flow is very similar. SMSDBmon will see the addition to the database and wake up Distribution Manager and tell it there's a package out there that you need to process. Okay, so Distribution Manager wakes up. You'll see all this live in just a minute. Distribution Manager wakes up and begins to process that file, and it will make decisions based on the stage of that package. It could be that there's no source content for the file yet or for the package yet, so it really doesn't have anything to do, right? Maybe it's just metadata for the package, which, by the way, metadata for a package or an application or a software update, deployment, whatever, all of that replicates through ConfigMgr SQL replication, not file-based replication. It's only when we introduce source files into the equation that we start to move through this mechanism. So once we add source files to the package, Distribution Manager realizes that and will start the process of working on those source files. We'll compress the source files. Why? Because it's more efficient to compress the content and send over the compressed copy than it is to send over the expanded copy. Maybe in the case of a 1 gig source directory, you could compress that down to 500 meg. Far more efficient to do that than send the entire gig. Right? Then there's another component that typically comes in line, at least in previous versions, called Replication Manager. So for content, in the example we're going to see, you're going to find Replication Manager really isn't involved at all. But it is for certain parts of this. So Replication Manager is one of those pieces that may or may not be needed depending on what is being replicated. All right, and I'll show you that when we get to it. So Distribution Manager, in order to send the content it's just compressed, it wakes up another component called Scheduler by putting a job file into Scheduler. Scheduler sees the job file, sees the work that it needs to do, and will prepare the system, figure out all the instructions, and then ultimately hand it over to a component called Sender. Okay? So then Sender's job is to move that content, whatever it is, across the network. Could be that we're throttling the network for site-to-site communication, could be whatever, and ultimately it's going to deliver it to the single component on the receiving server called despooler. Now, a word about throttling for a minute. So in previous versions of ConfigMgr, secondary sites were a pretty popular item because in order to do throttling to a distribution point that is hosted on a site server that is across the WAN, you needed a site there. In other words, you could not throttle communication from the site to its distribution point directly. Right? You had to have a site server there. That's no longer true in Configuration Manager 2012, as you'll see. So if I don't have any distribution points on the CAS just because of the nature of what it is, but if I had a distribution point on this primary, off this primary, and I wanted to throttle that, have that distribution point across a slow network, throttle the communication, I can absolutely do that. No need for a secondary site. The beauty of that is the vast majority of the reason for a secondary site in Config Manager 2012, it doesn't exist anymore. 95, my numbers, % of cases where customers use secondary sites in the past were because of this throttling concern to the distribution point. Right? Now we can do that directly. You'll see that a bit of a preview as we go ahead. And then once despooler gets the content, it will act on that content, unwrap it, essentially decompress it, and then take action. So that action, despooler may hand it to Replication Manager in some cases, or in the case of the content we're going to look at, it hands it directly to Distribution Manager. Distribution Manager will now see that the content is destined for a distribution point that is local to this site, and we'll just put it out there. In this case, the distribution point is co-located. On the site server, we have the content store there, so it just puts it out in the content store, right? If we need to. There, probably my demos, I have all this content in the content store already, just from all the work I've done on my lab. But still, we'll see the work as it goes through the motions. Okay, so this is the longest demo of the three. And so I'll go through this in detail, and then we'll have two other demos that kind of build on top of this one, and they'll be a little bit quicker, but we'll take it end to end. So let's pull the lab in and take a look at it real quick. So here I have my CAS. This is my CAS server, and actually minimize this. That was my primary. This is my CAS. And what I have here is a replication demo package. It doesn't really matter what content it is. All I want to do, I don't have any programs, anything else. All I want to do is assign a distribution point to the content in this package and have it replicate through the file-based system and track it along the way. So I'll show you here that there are currently no distribution points assigned. This is a fresh, new created package I just did before starting this session. And what I need to do is distribute content. Now, I want to track the content as it flows through the system. So in order to do that, I'm going to disable several components that I showed you in the diagram so that we can actually wake them up individually, and you can see these things in action. So let me just run here, do this real quick. A word of caution. So what I'm doing in my lab is fine in a lab. This is not something you want to do in production. The reason I'm going to do it this way in my lab is because there are other ways to do this same kind of thing. But what happens is the system will recover itself and will restart some of the threads that I'm going to turn off. So I'm just going to go ahead and totally break them, totally disable them so that they don't run. And I know when I'm starting them back up, and so we can watch the progress go through. So let me go to the Config Manager directory. All right, and the nice thing is, if you look at the log file names, the component names that all run under the executive, they have pretty descriptive names. Okay, let me go in here and look at it. So for example, if I go into the Program Files directory, Microsoft Config Manager logs, so all these logs represent, they're kind of a shortcut name for the components that are running under the executive. So in the case, one of the ones I'm going to stop is Distribution Manager. So you see there's a distmgr.log. Then there's going to be REPL Manager as one of the components that could be involved in this. And you'll go down and see a REPL mgr.log. Well, the nice thing is these components names are the same over here. So I'm going to, for example, stop or disable Distribution Manager. Okay, so notice that the executive, I'm going to have to restart it in a minute. These are all threads of the umbrella service called the executive. So the executive can run, yet I'm going to disable these threads. and be able to track some things. The other one I'm going to do is schedule. And then finally, helps if I type this correctly. And then finally, I'm going to do sender. Okay, good enough. So now I'm going to stop the executive. And while that's stopping, I'm going to go to my child primary and rename some threads over here that will be pivotal on the receiving end so we can track this thing. And notice I'm not renaming REPL Manager because I know REPL Manager is not involved in this process. I'll show that to you. It is involved in some. Again, I'll show you some entries in the log accordingly. Go to the same directory. And here I want to rename despooler. Good enough. And one last component, again, distribution manager. And restart the executive. If I can type, go up to my CAS and should be stopped so I can restart it. Oops, minimize. Good enough, so we'll start it. Okay, it's starting, so let's see on our child primary. We'll wait for it and then restart it and come back. Oh, there we go, quick as that. So let's start. Okay, so it's back up and running. So we'll continue on. So the component that I did not disable is SMSDBmon, right? Because that's the piece that watches the entries in the database and creates notifications for other components to go to work, right? So I want to have that one still live. No need to hobble it at all. So I'm going to go and distribute content. There's 3 distribution points ultimately that I'm going to add to this content. I'm going to do them one at a time. So the first one is the distribution point that is co-located on the site server itself, which is this one. So I'm just going to click OK, click Next. And as easy as that, I've added the content. Now, what happened by me doing that is there have been some entries added to the database tables to say, take this content that is referenced by the source directory and package it up so that it shows up on the distribution point that I selected, right? That all goes in the database, no problem. But no components know to take action on it until they're told to. And SMSDBmon is the thread that sees that happen. So let me show you what I mean. So this particular package that I created is ID 44. So if I go into SMSDBmon right here and open it up, I should for sure have entries here where we've seen the insertion into the database and we want to replicate the content down. So here we are. We can tell by timestamp that we woke up around here somewhere, and certainly we see CAS 44 and some information that we had some inserts happen on the PKG notification table. That is a table in the database in case you weren't aware. And as a result, we're going to write a notification file. Right? We're going to drop this CAS 00044.pkn into distributionmanager.box, which is the first component in line and the one that we just stopped. Right? So that's SMSDBmon watching the database and then dropping details in the inboxes to wake up various components to go do their work. So let's look in the inbox real quick. So if we go, this is schedule.box, let me back up. If we go to inboxes and go to distributionmanager.box, here we will see a PKN for the 44 package, the package with the ID 44 that I just created. Notice these are zero-linked files. They're completely empty, which is another interesting thing. If you do happen to know the flag files that ConfigMgr uses, in some cases you can use those flag files to trigger some activity in the system to reevaluate a condition or do whatever, right? Be careful with flag files because some of them contain text or contain what looks to be editable, but if you were to go edit it, you would corrupt the file. Right? I'll show you an example of some of those when we get to schedule.box. So just be careful, make sure you know what you're doing. But in this case, these files are flag files. They're going to wake up the component, and let's go ahead and wake it up ourselves so we can watch it process. So the way we do that is rename Distribution Manager old to Distribution Manager DLL, restart the executive, so that may take a second or two. Okay, so that stopped. Let's restart it. There we go. There we go. And so now we should see those flag files very quickly start to be processed. If I go, in fact, to my logs directory and open up Distribution Manager log, right here. There we are. We may actually see those files disappear before we can get in the log. Looks like they're being worked on. And in fact, they are already gone, right? So what we can do is just pause the log. It looks like it's finished with the processing. And scroll up. So anytime you're looking in these logs, the timestamp is definitely your friend. You want to see what the time it was that there's a gap, right? So we had disabled this component and then we started it back, so that makes sense. This is a little bit of a gap here. So we started Distribution Manager. You can see that it found the notification files, that there's work to be done. Here's one of the three that is ours. Package 44 is the ID. So we're going to start working on it, right? And so let's just follow this down a little bit. And here we notice that we need to send a compressed copy of the package down to our primary site, which is our child site, right? And so we're going to do that, sending a copy. But before we send it, we have to compress this, because again, compressing is more efficient than sending the uncompressed version. In this case, it's very small, doesn't matter. But in production, you'll be sending some large things. We compress our data here. This is the content we're going to send, right? So in the compressed form, we're not very big, right? Just a little bit. But here, this is the directory that you will see referenced in some further logs as we're getting ready to send the content. All right. So let's roll on down. There's a few other packages being worked on in here, so a few extra lines. Here we are, that the mini job transfer root is that folder and is that PCK file that I just showed you. And then we're creating a mini job to send the compressed content down to PS1. So what actually that means is Distribution Manager doesn't actually send anything. It gets the environment ready to send, but it actually doesn't do the sending itself. It will actually ask another component, called in this case scheduler and sender, to send the data on its behalf. In order to do that, we have to create a mini job. So if we were to look ahead, and we will now, into the schedule.box folder, you will see that there is a job, which is a request file to scheduler to send data. And here it is. Now, scheduler is not turned on, so there's really not anything to look at in the logs, at least not yet, right? A little bit of a diversion from the way this used to work. So in previous versions, you would actually have Replication Manager involved in this process. So let me divert from this a minute. So that's really all for Distribution Manager. We've got the request made, the package has been compressed, and we're ready to send. So Replication Manager, though, you'll see is not involved in this process at all. So if I go look at REPL Manager log, right here, you'll definitely see the activity as the executive has been stopped and restarted, but you won't see any activity at all for Replication Manager has to be involved in getting a job ready, preparing anything, right? It's just idle right now. Now, if you search REPL Manager log, you'll see that it does handle certain traffic, like maybe in the primary in this case had sent a discovery record in So it's replicated using the Replication Manager thread to marshal things out, and it's moved around. But it's not really doing anything with our content, our package content. The synchronization file for WSUS, you'll see that it moves with some Replication Manager stuff going on. But for the lion's share of what we're doing, Replication Manager is not involved. Okay. So now that we've got the job in schedule.box, let's take a look at it before we turn it back on. There's a few folders here. So this one is interesting. I'll just go through these one at a time and stop and show you some of them. This is the only one that really has content in it right now. So scheduler is, as the name implies, an engine to allow scheduling of content going from site to site. So in a production environment, you'll have a lot of content potentially going from site to site. We'll have to figure out the priority of that content. We'll have to keep track on that content as it moves and just maintain the schedule. This can be a very busy component on some site servers, right? Well, as we work, we have to increment a counter so that we know what our latest job count is and different things. Well, that's what these files are. These are very basically counter files, and there's no need for them to have content in them. In this case, they do, right? This is in ConfigMgr 2007, they did not have any content. In 2012, they do. But the point of this is, it's really important that both of these files be here. If one is gone, or both, your sending from site to site will not work. A very common scenario, which I've seen even in 2012, is where we have virus scanners set for on-demand virus scanning. And this file in a busy site gets opened and closed so fast that the virus scanner may not let go of it. So what happens is we open the file, rename it, delete it, try to save it back out, whatever. The virus scanner probably still has it in that transaction. We can't write the file back, right? And so you end up having a system that's broken. The sender isn't working, or the scheduler or the sender can't work, right? So be aware of that. And it's just not a good idea to have on-demand virus scanning on the ConfigMgr inboxes folders, and I don't like to have it turned on for really any of the ConfigMgr folders. Certainly virus scanning needs to be turned on, but not on demand. All right. So the toSend folder, when we process the job file and start to see what it is we need to send, we will put some information in toSend so that we know exactly the parameters and things that need to be sent. We'll also create a file here telling what we're going to send. So we do have a couple of files in here. These are not files that you should ever mess with, right? Once I start scheduler back up and we schedule the sending, you'll see a file come in here waking sender up, telling it where to go get the file to send, and you can watch the sender process work, right? So right before I open up and reschedule sender, let's open up this job file. So you can open it up in Notepad. You see a lot of gibberish here. You could edit this if you wanted to, but if you do, you're going to break this file. So you can see for sure what this is. Here's the name of the software distribution we're going to send, package. Here's the ID, and here is the transfer route. This is the SMSPKG folder, and there's some other details through here, some encrypted things as far as permissions and so on. But you get the idea. You can trace this. So it is better, as I recall, I don't remember the 2007 exactly to say this for sure, but my impression is there's a couple of things in these files in 2012 that actually makes this easier to track. But it's still hard to piece these files together totally without knowing what to look for. But the information's here. And so this job file is basically telling scheduler what it needs to schedule and where it's going to go, right? And so on. So, and you can actually see the package source directory here, what we're sending down, and there's more details in here. All right. Okay. So let me close this file out, and let's go ahead and restart scheduler. I did that exactly wrong, schedule.old. All right, and then we'll stop and restart the executive. Okay, so let's start it back up. Good enough. So while that's coming back up, let's open up scheduler log. Now, in my environment, a test environment is a great way to look at these logs and get a sense of what they have. In a production environment, scheduler log can move so incredibly quickly that you don't really get a sense of what it's doing, right? Let me pause this and show you a couple of things. So if I go up to where we started up, let me go to the top of the processing loop after the executive restarted. Here we go. So right at here. So we started up. We're checking to see if there's any send request in memory, send request on disk, any completed jobs. So in this case, that job file, so like in Distribution Manager, you saw that PKN file, that notification file, go away right after it was processed. You won't see that with the job file. The job file will get deleted when scheduler has confirmed that it's been sent and the job no longer needs to be acted upon. That's what you see right here, deleting any completed jobs. It will loop through this on occasion and take care of cleanup. And then checking, memory and different things, sorting our list of any send request. We don't have any right now, obviously. Sleeping, and then checking again, updating. So we don't have any jobs in queue in memory, but we did find one in the job source, which is our directory, right? And so we open up that job and we start to read it, that encrypted information the system knows how to read, and we realize that it's now being activated. Here's the job ID, 12F, which prior to ConfigMgr 2012, the files, at least as I'm recalling, you would have to keep track of the job ID and the package ID and all of these things to stitch this process together. You'll see in a minute that these files actually do contain the package ID consistently, so it's easier to follow. But you'll see the job ID again, 12F. Here's our destination site. Here's our priority, so that's normal priority. We're creating an instruction file, so now we will have content in toSend. So if I go over to toSend, you'll see there's information here. And outboxes should have something too, request doesn't. And now we have a third file in outboxes telling us what we're going to send. Okay, and then we have the transfer route. That again is the SMSPKG folder I mentioned and showed you. Making sure the signature matches. It does. And now we've activated the job. Okay, so creating new send request. And off we go. Let's unpause this. Okay. Scroll up a bit. Yeah, here we go. Creating new send request here. So this is where we were. So rolling on down, we're now active and we have our send request. This is the job ID we just saw, 12F. Here's our destination. Here's some details about the job. Now, what's interesting is sometimes you might want to know. You might have a lot of content going through the site-to-site sending mechanism, file-based, and you wonder, why isn't this piece of content moving? What is taking so long? Is it actually in progress? That kind of thing. Well, scheduler tells you all of that, right? So right here, if you look, now obviously I haven't moved it all yet because sender's disabled, but you can see total size, how much is remaining, and more detail about this, right? So in the case of a few customers through the years, I've had to go in and track that through in scheduler, which is harder in a production environment because it's moving so quickly, but you have a lot more going on. But when you find this line, you can find the package that you care about, and you can see how much is going on. So in the one case I'm remembering, it was a 2 gig package that someone had pushed out, and there was nothing else really moving. And so in this case, we had to figure out, okay, we've actually sent 200 meg of this 2 gig package. It's going to be a while yet. No real way to easily clean it out of the system, so we're just going to have to wait until this thing processes through. We can keep track on it in the log and see how it's moving and things like that, but there's nothing wrong. We're telling the status right here, and it's just going to take time because it's a lot of content, right? So it's useful information here in the log. And then once we have the job active and such, scheduling is really done. The next pieces would be after sending is complete. to come back through and clean things up. But we are where we are right now, waiting on sender, so we won't see that part of it. Right, so back to the send request to send. This file you can open up too. Again, don't change anything. You can look at all of these and see some more encrypted detail. You can see the various groups that are going to be added in terms of security. You can confirm again what the name of the application is or the packages that you're sending, the ID. Here's the job ID that is in the scheduler now, and different things. Right? You can go over to sender, and even though outboxes is under schedule.box, this is actually the folder for sender. You can open up the send request. You can again see the destination site code. You can see this ID, right, for the job ID. You can see where it's going to get its content. The to send is actually telling us what to send, right? And then here's the transfer route. This is the actual file that's going to be sent over. So it's a lot of detail, but hopefully it makes sense, and hopefully you can stitch some of this together now. All right, so let's go and enable sender and let this move across the network. And we'll start and stop the executive again. Stop. And I'll start it again in case you haven't noticed. I am pausing the video so you don't have to sit there and watch the executive stop. So it started, and so sender should now be active. Now you're not going to see these files necessarily go away because they aren't really notification files. They're kind of instruction files that tell the system where to go get data. But you will see sender start to send, right? Because now we've woken it up, and it's not a ton of content that needs to send over. But so you see, we'll again keep the timestamp kind of as our friend here. There we saw, right about here. So we wake up and we look for capacity. We check to see if we have anything to do. And we look and we found that we do actually have a send request. It's going to our destination site, PS1. You see the ID of the send request, which I don't know if I didn't call it out, but it was there earlier in one of the flag files. We're creating a thread to begin sending, and then we passed the test, so we're going to actually be able to send. There's no blockages. We're good to go. Everything's scheduled. Here's the file we're going to send. There's that transfer route where we have the compressed copy, and then we're going to start sending, right? So we're writing the data of that PCK file over in chunks to this folder on the destination site server, PS1, called SMS_site. Now I remember when I first started looking at this that I could not find a folder called SMS_site. It drove me crazy. Well, SMS_site is not an actual folder name that's on our destination server. It's a share name. I'll show you that in just a minute. So it doesn't take us very long, and we finish sending our data and make sure that we can open up and recreate and rename some files, because notice the temp extension, right? So the temp extension is there so that the component on the receiving server side doesn't start to process it until we have all the data there. And then we'll rename it, as you see here, rename completed, and that's it. We back away and we're good. So at this point, we have completed the sending process from the CAS down to our child primary. And we can go to our child primary and pick it up from there. All right, so we have a couple of threads stopped on our child primary. So one of them is despooler. So let's go into this directory. It's actually logs, and we back up a level. Oops, I do want that directory. Here, let me go in here. So if I go under inboxes and go under this thing called despooler, there's a folder in here called receive. Well, if you go to properties on this folder and you look at the share permissions, you'll see that the share name for this folder is SMS_site. That's where that folder name comes from. It's not an actual folder in place on the system. So if we look under receive, we see two files. Here's the PCK that we had on the CAS, and it's now sent here, and then here's the SNI. So the SNI, again, like anything, can be opened up in Notepad, and you'll see some details about what this is. It's ID 44, it's the name here, and some of the same details. This is an instruction file that tells dspooler what kind of content this is, and therefore what component to hand it off to, right? So everything, doesn't matter what it is, comes into the dspooler box, is sent by sender into the dspooler box, and then dspooler opens it up and figures out what to do with it. In some cases, it might hand it to Replication Manager, and Replication Manager will work on it. Specifically, well, I won't go into that scenario. Replication Manager will work on it. In this case, it's just going to hand it directly over to Distribution Manager. So let me restart dspooler. Okay, start the executive again, and we'll start it back up. All right, so good enough. And so we'll see these files maybe go away, maybe not. Let's get into the log file dspooler, and it will act on these things. So dspooler, right there. Minimize this now and pull this to the side. Yeah, those files now are gone. And so following the timestamp, scroll up a bit. There we are. So executive started dspooler, found one dspooler instruction, and we found it. It's ready to go. There's the SNI. And so we created a despooling thread. We're going to look at it. The file comes from the CAS, so we have to validate the content against the CAS encryption key. It passes, and now we have to act upon it, executing the instruction here, and we have this package ID. The compressed file is stored from this location, right, or being stored from this to this location, even on this server, and we're using drive C to store it. We're putting it here, right? And then once we get finished, we are finished executing one instruction. So you don't see anything here, but if you look now in distributionmanager.box, you will see that we have a file, a package notification file, ready for action. Right, so let me go back to inboxes, distribution manager box. Right there. Here's 44 and a couple of others. Right? Now, so in this case as well, Replication Manager didn't do anything. Let's look at the Replication Manager log to confirm that. And there it is. So you see executive starting up Replication Manager, but just like at the CAS, there's nothing that Replication Manager does in terms of processing these files. So dspooler knows that it's a package. It puts a notification file over in Distribution Manager. Here it is. So now we're going to go ahead and wake up Distribution Manager and let it start to process. Stop and start. And so we'll start it. Good enough. So if we go to Distribution Manager log now, then we'll see it start to wake up, and really it's not going to be all that exciting just as it finishes up the processing thread. So here, executive restarted. We found some package properties updated for package 44, which is brand new to this site. Found a few other notification files down here, including 44. And so we're going to go through and start to process the package, start updating package 44. We're using drive C for storing the compressed pack. Well, that's actually, sorry, that's for another package. Successfully created update, and really that's just about it, right? Not a whole lot more. Just putting it in the content store. Just making sure there's nothing else about 44 in here. As I'm scrolling down, I'm not seeing anything. Anyway, you get the idea here. Created policy provider trigger for 44. Different things we do as we put the content in the store. And that's it. The content is now at the site server and also the distribution point for that particular site, right? So that's the detailed process as we go through. And that is really classic site-to-site communication, file-based site-to-site communication. But as I mentioned earlier, in 2012, we think about file-based site-to-site movement really in terms of getting content to the distribution point. So I'm going to continue with a couple of extra examples, right, to show you getting the content to the distribution point at the child primary site in a couple of different scenarios. So let's go look at that. All right, so for this scenario, I'm going to add a little bit. So all of the process that we just talked about, all this top part is going to be the same. So there's no reason to go through that again. What I will do, though, is notice that in this diagram, I've added a distribution point that is remote. It is not part of my primary site. So I have to go through the process of getting the content not only to the primary site, but also out to the remote distribution point. That introduces another thread called Package Transfer Manager. Package Transfer Manager is very similar to Sender and Scheduler. In fact, it looks like it combined. There's some differences. But if you look at the folder structure, if you look at some of the log entries, it looks like both Scheduler and Sender combined into one component. Right? It makes sense because Package Transfer Manager is responsible for sending content to a remote DP, and it's also responsible for scheduling things. It's also responsible for throttling that communication to that remote DP. Mentioned earlier that the vast majority of the reason that customers have secondary sites historically is because they were concerned about pushing content down to a distribution point that happened to be at that secondary site. Well, now you don't need the secondary site. All you need is a remote distribution point. We can throttle content to the remote distribution point. It works great. Right? I'll show you throttling a bit in a minute. All right, so let's go through this in the lab. And all I'm going to do is go back to my CAS, and I'm going to add in my remote distribution point. Okay, so add this in. Take it a minute to replicate as it moves from site to site. That is it. So I'll add that in, and then we'll go to the child primary, and we'll wait in the logs, specifically the distribution manager log, to see that it's going to send the content out to our remote distribution point. So I'm going to pause the video and come back when that takes place. So actually, one of the things that I decided to do, forgot to do, before I put the video on pause, and I'm doing it now before the content gets down to the child primary, is rename my Package Transfer Manager. Okay, so we now have the package down here, and we see that we found the notification file. Here's package 44, the one that we care about. We're starting the package processing thread. Notice this time we are updating our remote distribution point, so that's working. So we're attempting to add our content, no problem. And now we made a successful network connection over there to our remote site, connecting over, just checking some different things, checking signature shares, continuity, and so on. And checking to see if it has a preferred sender. It doesn't. And then basically that's it, or so it appears. Right? So let's take a look. Okay, so if we look in Package Transfer Manager, what you don't see in that log is that in order to service that remote distribution point, we're actually handing off to Package Transfer Manager. And this is that flag file, the same flag file that you saw for Distribution Manager. Here's a UID folder, which looks very similar to what we saw at Scheduler. We don't have any files in there, though. Here's a request folder, don't have any files in here, and here's an outboxes LAN, which looks very similar to what was under schedule.box, no files in here either. But the structure looks very similar. So now what I want to do is go ahead and enable Package Transfer Manager and see what happens. Okay, and now we're going to stop and start the executive. I'll type it. And now we'll restart. Good enough. So now we've restarted. Now we should see this package notification file get processed. Let's go pull up the Package Transfer Manager log. Right here. And unless I made a typo, we should see everything come back to life. Here we started. So we're looking to see what we have. We found a send request, forecast 44. We're starting our send request and we're sending it over. Now in my lab, it's a pretty boring operation. I just have that one file. In a busier environment, you'll see a lot more activity in here. But you notice in this log that it is tracking the send request. It's actually doing the sending. You'll see some additional detail in here in larger production environments as well, right? So now that content is out on our remote distribution point. We can validate that by looking in the content store if we want to. We could have done that on the main site server. Hey, let's do that. Just for grins and to take some time here. If we look in the content library on our distribution point under package lib, we see that package 44 is in fact here, right? If we look at the same folder over on our remote distribution point, there we go. We'll see the same thing. Here's package 44. We just put it there. And then let's proactively look at the package folder on our other distribution point we're going to send this to. And we can proactively see it's not there, right? So should have shown you the other two first, but now we at least see it's not there on our third one, all right? So now let's move on and do our final demo, all right? So let me pull this down, pull the lab out. So not hugely different, a little bit different, right, by adding the remote DP and other components involved. Well, in 2012, we have this component that we add now, 2012 R2 SP1, called the pull DP. Pull DP is interesting. I've got it laid out on the diagram well. In my environment, I'm not doing exactly like this just because of my lab, but the pull DP is really geared to address a scenario where you might have a single primary that has maybe 10 distribution points, and maybe 8 of those distribution points are across a slow WAN link. So you have a question, you have a choice. Do you want to put a secondary out there, or do you want to tolerate the hit on that WAN link of replicating your content to those remote DPs 8 times, right? Which is not huge compared to the clients coming across that slow WAN link, but still it's a lot of traffic across this slow WAN link, right? Or would it be better for you to have a scenario where you choose one of your remote DPs across this slow WAN link that will receive the content directly, and then any distribution points that are behind the slow WAN link but are very well connected to your remote DP, you could actually have them pull the content from this remote DP. Let me show you how that looks in the console. So if I go into administration and look at my distribution point list, you will see here's my pull DP. So if I go to properties of it, under pull DP, you'll see that first of all I have to enable a distribution point to be a pull DP. Pull DP simply means that it's not receiving the content directly from the site. It's going to only receive content from a peer distribution point. The whole idea being if your peer distribution point has your fast network connected to that peer DP, whereas your slow network connected to your site, you can still very quickly, very efficiently get your content from that local peer DP, or partner DP, the DP that you're going to pull from, source DP, I guess is the official name, versus having to go back across the slow WAN link. So in this case, I've just configured that my source DP is the site server. That's where it differs from the diagram, but it still works the same. This DP I can select just like normal operations, but there's a different mechanism that takes place to notify it to get its content from one of the peer DPs or one of the source DPs listed. All right, and I can actually have more than one source DP. I can set priority and so on. All right. Okay, so let's actually go make the change to add that. Actually, before I do that, I'll make the change to add the DP, and I'll show you a little bit more on that diagram real quick. So I'm going to distribute the content, add in my last distribution point, the pull DP, and that's done. So now while that's processing, let me pull the lab back out of the way. And so what's happening is we'll trickle all the way down and get to the primary. It will actually it's already staged out in this case to the remote DP. So what happens is Distribution Manager knows that ultimately it needs to get the content out to the pull DP. But it also knows that it can't send it to the pull DP directly. But it knows that there is a source DP that the pull DP can pull the content from. And again, in my case, you're going to see that the source DP is my primary. Just a little bit of weirdness about my lab, but this is the typical scenario. So what happens is Package Transfer Manager, Distribution Manager will see it's going to the pull DP. That process will wake up Package Transfer Manager. And Package Transfer Manager will not send content to the pull DP. What it will do is it will send a package information bundle over to the pull DP, which simply tells the pull DP what content it needs to download. And so the pull DP will then go to its source DP to get it. Right? So this communication is tiny. There's nothing to this. This communication is a lot bigger. So this is seen as not being a big deal. This is seen as the biggest cost savings, right, for network traffic. So let's go look at that. So let me pull up my primary site server, and what I'm going to do also is pull open my pull DP. All right, and I'm going to, let me do that real quick. Pause the video while I do it. I'll be back. Okay, so that's done. I've got a connection now. So let's pull this back out for a minute. So what we're going to do is we're going to pick this up from Package Transfer Manager. So whenever we send to the pull DP, same process. Ultimately, Distribution Manager will realize it needs to send to the pull DP, but it can't send to the pull DP directly, right? So what it's going to do is it's going to hand off to Package Transfer Manager just like before. But again, Package Transfer Manager cannot send to the pull DP directly the content. But what Package Transfer Manager can do is send this package info bundle to the pull DP, telling it where to go get the content, right? So let's watch that take place. So I've added the pull DP, and we've followed it through to the Package Transfer Manager, and now Package Transfer Manager knows that it has found a send request for this package going to the pull DP. So as we process through, we're going to send the package info bundle. We're starting the job, sending the package info bundle to our pull DP. Successfully performed our WMI action and sent that over, sent the notification over. Well, what is it actually doing? Well, it's communicating with your pull DP. And what I've done is I've stopped the service so we can't process that. And you can see that through services, SMS agent host, so that's an interesting point too. The pull DP is a component of the client service. In this case, the box is not a client. It's just a pull DP. Could be a client too, right? But I've stopped the client because I don't want it to process anything. But what we notice if we go into WMI, because you saw WMI in that log over there, and connect up to a new namespace now. It's not the CCM namespace. It's root sccmdp. Right? And go down, enum classes, recursive, okay, scroll all the way down. There's several namespaces here. The key one is this one called SMS underscore pull DP notification. So if I open this up and look at instances, you're going to see that there is in fact a notification parked here telling the pull DP that there's something to do with this particular package. Right? Now, what is there in terms of information here? Well, let's look at, let's double click on it and look at it. So show off. There's 3 lines, the ID, the package version, and an XML snippet. Well, if we scroll across, we see some of the common actors such as the package ID, such as the whether we allow fallback, the kind of things we might see in a location request, package flags, that kind of thing. We keep scrolling though, and what we'll see is, again, the package ID, any related content, maybe dependencies or whatever, which we don't have in this case. And then notice the distribution point location, and this is going to be one of our source distribution points where we can go retrieve that content. Okay, any retrieval protocols, where the package is located, and different things, right? So this is notifying the pull DP. Let me go ahead and start my service again. This is notifying the pull DP to go out and provision this content and telling it where it can go. So I'm going to go ahead and start this up. Oops, it's disabled. Let me go ahead and get that taken care of, and then we'll start it. Okay, good enough. So it'll take a minute for that to spin up, so I'll go ahead and pause the video and come back, and we'll take a look at the pull DP log. Okay, so now that we have that up and running again, let's explore the pull DP for a minute. So you notice that I'm in the logs folder, and the logs folder just looks very much like a client installation folder. It is, right? This is not a full client, it's just a pull DP, but nonetheless, the logs look very familiar, but there is one additional log called the pull DP, right? So if I open this up, I can go down, scroll to the bottom. All right, let me scroll to the top of this processing loop. Here we go. And you can see that we've got a job that we've loaded. We're verifying the hash. We're starting the download of our content now, which is the actual files. Here are the files that are coming down as part of the package. And then really that's about it. We've got it all stored. If we go look at the distribution point, which we will now, oops, let me go here. Here we have our content library. We have our package library. Here's our file, so we know that it's arrived. And then we have over here, here's our distribution point. There's some content there. That probably is residual. Regardless, is our SMS folder. Logs for the pull DP that aren't really relevant to our discussion here. DP provider log, and so on, right? So the pull DP now is provisioned with the content as well. All right, so that's really it. That is kind of end-to-end the flow of moving file-based content around in the hierarchy. One more thing I wanted to just show you. So I've mentioned throttling a couple of times. So we have a couple of different types of throttling. We have site-to-site, which is that scenario where you're just basically moving content from one site to another, typically a CAS to primary, or historically a primary to primary, right? Primary to secondary. In this case, it's also a situation where we have the DP co-located on the receiving site. You can definitely throttle this traffic, right? That's very doable, the same way it's been done for years. Well, then there's site-to-site transfer that ultimately is headed for a remote DP. And with 2012, you can now throttle that traffic through Package Transfer Manager on an individual DP. So let me show you how to configure throttling just to close this out. So if we go into administration, and then we go up to hierarchy configuration, we'll have the file replication, this used to be called addresses, right? And if I go into any of my addresses and go to properties, I will have the ability to schedule when that address is open and configure rate limits. This is just for site-to-site communication. This has always been there, just been named differently in 2012. But now, if you go to distribution points and go to, this is my remote distribution point, go to properties here, you'll notice that this is a full DP, and because it's a full DP, it now has itself a rate limits tab. So you can set rate limits on an individual DP, and Package Transfer Manager will respect that. Well, the next question you might have is, can you set rate limits on a pull DP? The answer is no. There is no rate limits tab. So the assumption is made if you have a pull DP, you're going to have a source DP that you have good connectivity to, so there's really no concern about limiting the rate like you would across a slow WAN link, right? So that's those are the two places you can configure throttling in ConfigMgr 2012. So that's it, right? Wrapping up the session. That's file-based replication, very similar as it was to 2007 with a few tweaks. So we'll wrap session 2, and then in session 3, we will talk about ConfigMgr SQL replication, and we'll talk to you then.